Hi everyone, this is Algebra 2, Unit 1, Lesson 5, Multiplying Polynomials. The first thing I want to talk about is the actual multiplying exponents rule, and I'm going to show you where it comes from. So if I were to write this out, do you agree that there are 5 x's here? And then it's being multiplied by 2 more x's. Now, if I were to simplify that, well, my base is x, and if I count how many I have here, I have 7. So if you look at the original, how do you get to x to the 7th without doing all that work? Well, you add the exponents, right? But I just wanted you to see where it comes from. You're going to keep your base, right? Now, sometimes you're going to have a coefficient. So, for example, if I have 2x to the 3rd times 8x to the 4th, if I follow my rule, my base is just x. It's just the number below the exponent. I'm going to add my exponents together. And then what do I do with the numbers in front, the coefficients? I'm going to multiply them. So you do actually do some multiplying. Multiply coefficients. Okay? So if we now look at our notes for Lesson 5, multiplying polynomials. Polynomials are expressions that are combinations of terms using addition and subtraction that can only have constants and positive integer powers. For example, 2x cubed minus 3x squared plus 5 is a polynomial. To be more specific, there's 3 terms, that makes it a trinomial. However, x to the negative 1 plus 2x to the half plus 1 isn't. That's because the exponents are not positive integers. When multiplying polynomials, the distributive property will be used. An area model will also be shown. Let's start by multiplying binomials. How many terms does a binomial have? Well, BI, like for bicycle, stands for 2. And if you look in the 2 examples in exercise 1, a subtraction sign separates the terms. There's 2 terms there. Plus sign subtract. In the second binomial, divides the terms are being separated by an addition sign, but there are 2 terms there. So they want us to multiply them together using the distributive property twice. So most teachers, I believe they say double distribute. I'm not sure if there are any that still use the FOIL method. It's basically the same, but you would just hear the word FOIL. But I'm going to double distribute here. So I'm going to take my first term and I'm going to multiply it by everything in the second term. So 3x squared times x squared. Well, my coefficients are 3 and 1, so when I multiply them together, I get 3. I keep my base of x and I add my exponents. Now I'm going to multiply 3x squared by 1, and that's 3x squared. But then you also have to double distribute. So you have to distribute this negative 4 to both terms there. So that's going to give me negative 4x minus 4. Now you should always check for like terms, and those are like terms. So I'm going to put mine in standard form, which means highest exponent first. So I keep my 3x to the 4th. I'm going to combine like terms, so don't confuse us. You're just adding or subtracting. So you keep the x squared. So you're going to do 3 minus 4 is a negative 1, and you keep the x squared minus 4. And that's your final answer. Now, if you look at exercise 2, it's a new problem. They want us to use double distribute. And then in part B, you will see, this is called the box method. Some teachers teach it this way. A lot of students like to do it this way because it helps keep you organized. But whatever way you prefer is fine, but I am going to show you both ways. So I'm going to double distribute here. I'm going to multiply my 3x by both terms and the second. So that's going to give me 6x squared plus 15x. And now I have to distribute the 2 everywhere. So that's going to give me 4x plus 10. I have my middle terms. By the way, 90% of the time when you multiply two binomials together, your second and third term will combine. So I have 6x squared, 15x plus 14x is 19x, and bring down my plus 10. In part B, what they did was they made a 2 by 2 box because you have two binomials, 2 by 2. The first problem they wrote down the side. If there was a negative there, you would put it in front of one of those numbers. And then the second binomial they wrote on the top. It doesn't really matter which one you put where. So now I'm going to multiply the 3x times the 2x and put my answer where they meet. So that gives me 6x squared. Then I'm going to multiply the 2x by the 2 and put it in the square where they meet, which is here, and that's going to give me 4x. Then I'm going to multiply my 5 times my 3x and put them where those meet, and that's going to give me 15x. And then I'm going to multiply my 5 by my 2, and that's going to give me 10. Hopefully you noticed it's the same exact numbers that were in part A. So I'm going to keep my 6x squared. I'm going to combine my two like terms, which are these two. And that's going to give me 19x and plus 10. Same answer. So whichever method you prefer there. Exercise 3. Find the product of the binomial and the trinomial using the distributive property or using an area model. All right, so we are basically triple distributing here. If you want to use the box, that's fine. I'm not going to. So I need to distribute that 4x 3 times and watch your signs in front. So 4x times 2x squared is 8x cubed. There's an invisible one here, right? 4x times negative 5x is negative 20x squared. And then 4x times negative 3 is negative 12x. Now I'm going to distribute my 3. So 3 times 2x squared is 6x squared. And then I'm going to do 3 times negative 5x, which is negative 15x. And then 3 times negative 3 is negative 9. Once you do that, you want to combine like terms with your exponents in descending order. So my 8x cubed is the highest, and there's nothing else to combine it with, so that's going to come first. Then I'm going to look at my squareds. So I have this and this. So when I combine those, I have negative 20 plus 6, which is negative 14x squared. Remember, when you're combining like terms, you do not add the exponents. Now I'm going to combine just my x's. So I have negative 12x and negative 15x. And when I combine those together, that gives me a negative 27x. And then my minus 9 is my constant. There's nothing to combine that with, so I'm just going to bring it down. And that is my final answer. You definitely want to double check to make sure you don't have anything else that you can combine. On the next page, it is critical to understand that when polynomials are multiplied, the result is equivalent to this product, and this equivalence can be tested. So we're just going to prove that the original is equal to the trinomial that we end up with. All right, so they want us to for exercise 4, consider the product of x squared and 2x minus 5. Evaluate this product for x equals 4. Show your work. So I am just going to rewrite this here. They're saying product, so I can write it right next to each other because that means multiply. And now I'm going to plug in a 4 wherever there is an x and evaluate. So that's going to give me 2, and I have 8 minus 5, which is 3, so that gives me a 6. Part B, write a trinomial that is the product of these two binomials. They're not telling you exactly what to do, but basically they want a trinomial. So that tells me that I need to double distribute. I'm just going to rewrite it. So when I multiply my first terms together, I get 2x squared minus 5x, and now I'm going to distribute the negative 2. It's going to give me negative 4x plus 10. A negative times a negative is a positive. I'm going to combine my like terms. Negative 5 and negative 4 is negative 9x plus 10. And there is my trinomial. Part C says, evaluate the trinomial for x equals 4. Is it equal to the answer you found in A? So I'm going to rewrite my trinomial here, and I'm going to use x equals 4 again. I'm going to plug that into here. Now this step right here, you can put it into your calculator. I just want to show you that that needs to be evaluated first. 4 squared is 16, not 8. And then when you go and you can put that whole thing in your calculator, you should get 6, and that's how you know they are equivalent. Part D, what is the value of the trinomial when x equals 2? Can you explain why this makes sense based on the two binomials? All right, so I'm gonna plug in x equals 2 to my trinomial. So 2 times 2 squared minus 9 times 2 plus 10. From there, I'm going to go and put that in my calculator, and why don't you pause and do that yourself? Hopefully you'll get the same thing as me, which is a 0. Now, can you explain why this makes sense based on the two binomials? So if I look at my original binomials, why am I getting 0? Well, if I put a 2 here, doesn't that give me 0? And when you multiply anything by 0, you get 0. Exercise 5 has us now multiplying 3 binomials together. So we're like triple distributing. It says multiply the first 2 binomials, then multiply that result by the third binomial. So they're saying multiply the first 2 together. So I am going to multiply the x times the x, which gives me x squared. X times 4 is 4x. Now I'm distributing the negative 2, so negative 2x minus 8. And I'm just going to bring down my x minus 7 so I don't forget about it because I haven't used it yet. I'm now going to combine like terms, so 4 minus 2 is 2 minus 8. And now this should look like what we did in exercise 3, where we have a binomial being multiplied by a trinomial. I like my binomial to be first. I like to take my x here and distribute it 3 times. Same thing with the negative 7. I do not like to take this x, distribute it twice, and then this, distribute it twice, and then that, distribute it twice. However, You can do it whichever way you feel the most comfortable with. But what I'm gonna do right now is I'm gonna put my x minus 7 out front. Remember, you can multiply in any order that you want. So what I did just there is mathematically correct. So I'm gonna multiply here, x cubed, multiply here, plus 2x squared. Here is negative 8x. Now I'm gonna distribute the negative 7. So negative 7x squared minus 14x plus 56. I'm gonna combine like terms, so my x cubed is by itself. I'm gonna do my x squared, so I have that, and that's gonna give me 2 minus 7, or 2 plus a negative 7 is negative 5. And now I'm gonna do just my x's, so I have this and this. So negative 8 minus 14 is negative 22x, and then bring down my 56 because that's a constant all by itself. Part B. For what three values of x will the cubic polynomial that you found in part A have a value of 0? What famous law is this known as? I'm just going to scroll up for a second. Remember when we did D, right? And we plugged in the 2 and we got 0. Notice how in the original, it's what made one of those 0. So that's basically what we're doing down here. So what is going to make my first binomial 0? Well, wouldn't 2 make that 0? So x equals 2. Now I'm looking at the second binomial, and what would make that 0? A negative 4. Okay? And the last binomial right there, x minus 7, what is going to make that 0? Well, 7, right? Because 7 minus 7 is 0. What famous law is this known as? I think I mentioned it earlier. It's the 0 product law. And the last question says, test one of these three values you found in B to verify it is a 0 of the cubic polynomial. So I'm going to take my cubic polynomial right there, and I'm going to rewrite it. And I'm going to use x equals 2. It's the smallest, most positive number. It's easier to work with. So I'm going to plug in 2 cubed minus 5 times 2 squared minus 22 times 2 plus 56. From here, you can do order of operations, or you could plug it into your calculator. I promise you that if you plug it in correctly, you should get 0, so you're testing it, and that is correct. Sometimes I'll throw in a little bonus question. You don't have to do them, but it kind of lets me know that you're watching the video, and then I like, if you get it correct, I like to give you some bonus points for your quizzes and tests. It is very important that you send your answers to me in a private chat. Do not post it in the Teams newsfeed. Are you ready? So here's the question.